Okay, so for example number 3, this is where it gets a little more complicated. I've got 2x over x minus 1 plus 1 over x minus 3 is equal to 2 over x squared minus 4x plus 3. And we're asked to solve for x equals some stuff. Just go ahead and find what x is. What do we do to get started? Well, in the last two examples, what we did is we multiplied by the lowest common denominator. Now, this problem is kind of rigged. The only thing that we have to do differently is we have to make sure we have all the denominators in prime factorization. You were taught this probably in the 6th grade. When you want to find the lowest common denominator, what you do is you take each number and do a factor tree and find the prime factorization for each number. And then you take the highest power of each of the primes and then you multiply it, and that's how you find the lowest common denominator. Well, that process still takes place and it still works in this application. It's just now we have x's instead of numbers. What do you think this factors to? The problem's kind of rigged. What do you think that factors to? X minus 1 times the quantity x plus or minus 3, right? These two things. Right? It's kind of rigged. So we know that, but how do I double check it? Well, let's just double check it. We have x minus 1 and x minus 3. If I multiply it out, I get x squared minus 1x minus 3x plus 3. Right? And so if we add these two up, this plus this equals this. So I can rewrite this whole thing as 2x over x minus 1 plus 1 over x minus 3 is equal to 2 over x minus 1 times x minus 3. Is that right? Now, in order to get a common denominator, what's this one missing? Well, it's missing x minus 3, right? Well, whatever I do on the bottom, I have to do on the top. Is that correct? What's this one missing? X minus 1. So I'm writing it in kind of small. X minus 1 here. Whatever I do on the bottom, I have to do on the top. So now at this point, we could literally ignore the denominators, okay? We could literally ignore the denominators, because if you multiply everything by the denominator one more time, the denominators go away. But we cannot ignore one thing. The one thing that we cannot ignore is the domain, and I'm going to squeeze this in here. What do we know about the domain? If this is our common denominator, what do we know about the domain? We know that x cannot equal 1 and x cannot equal 3. Why? Because that'll make the denominator equal 0. Is that right? You guys with me so far? Okay. So if we do all this work and we get a solution like x equals 1, is that a good solution? No. If we go through all this work and we get x equals 3, is that a good solution? No. So now at this point, the only thing we're dealing with is the numerators. Okay, so I'm gonna say x minus 3 times the quantity 2x plus 1 times x minus 1 is equal to 2. Okay? So now, from here, I'm going to push this through the parentheses using my distributive property, and I get 2x squared minus 6x plus x minus 1 equals 2. I'm going to clean all this stuff up. I've got 2x squared minus 5x. And then if I subtract 2 from both sides and then add the negative 1, I should get 2x squared minus 5x minus 3 equals 0. Okay? Now I happen to know that this is not factorable. Not with integers. So how could I solve that? Well, maybe. Well, wait. Let's see. Let's see. Maybe we can. 2x squared and then negative 3 here. This will have to be 2x. This will have to be x. So now there's only two numbers that I can multiply to get 3. It's 1 and 3. So I can maybe put a 1 here or put a 3 here. But now remember that these two numbers on the inside have to add up to equal negative 5. So I'm thinking if I put the 3 here, I'll get 3 times 2, which will be 6x. And if I put a 1 here, I'll get 1x. But either the 1 or the 3 has to be negative in order to make this a negative 3. So which one has to be negative, the 3 or the 1? The 3, because if I make this negative, this becomes negative, and that's how I get the negative 5x. Does that make sense? So this does factor. I misspoke. This is 2x plus 1 times the quantity x minus 3. That equals 0. So we say 2x plus 1 equals 0, x minus 3 equals 0. So x equals 3, and x equals negative 1/2. Those are my two solutions. Now, how could I verify that? The original equation that we were given was this. Oh, wait. What did I say about the solutions? We said that the domain, if x equals 3, x cannot equal 3. So what do I know about this solution? It's no good. Do you know what we call a no good solution? Extraneous. Somebody's been reading their textbook. That's good. Extraneous. It means algebraically I could solve and get 3, but practically when I plug in 3 it won't work. That happens sometimes. And so we say it's an extraneous solution. So now I really just need to make sure that 1/2 works. Now I can take the 1/2 and plug it into this original equation, but man, that's a lot of work. Anybody got any suggestions on how to do that? Graph it? How might I enter it into the graphing calculator though? What I'm thinking is I'm thinking that I will just graph the left-hand side of the equal sign, which is going to be 2 divided by the quantity x minus 1 plus 1 divided by x minus 3. And I'm going to graph that. And then on the other side, on the next equation, I'm going to graph the other side of the equation, which is this 2 divided by the quantity x squared minus 4x plus 3. Okay? And I'm going to graph those. Now those two should intersect at what point? Negative 1/2. I don't know. I'm looking at negative 1/2. I don't see any intersections. So let's look again. Did I plug it in correctly? I've got 2x divided by x minus 1 plus 1 divided by x minus 3. That looks correct. 2 divided by x squared. Oh, do you see my error? I see it. I forgot this little x. Do you guys see that? Makes a difference. What do you think that intersection right there is? I think that occurs at net x. Let's zoom in on that and see what we get. Let's zoom in over here and see what we end up with. So this is 1, negative 1, so it should intersect about right here when x equals negative 1/2. Now I can verify this by just simply going second trace and finding the intersection of the two. Whoops. Huh, I hit the wrong thing. Negative 0.5. See it? Right there, that's where they intersect. Any questions?